So, good afternoon, everybody. My name is Paul Nash, and I manage the product team for Google Compute Engine. So today is an update from last year's talk, which was called Saving Money on Compute Engine. So this year it is Saving More Money on Compute Engine. It's right there. So just out of curiosity, how many of you might have seen that talk, either online or last year even, by show of hands? Excellent, good. All my jokes are good then. But to get a little sense of what we're going to do here, I'm going to show you all the different ways that we have where you can save more money on Compute Engine. Apart from the fact that all of you are new, how many of you are currently Google customers that are using either GCE or a product that you believe runs on Compute Engine? Show of hands. OK, great. Awesome. Thank you. So now a little bit of a quiz. Sorry, it's after lunch. I did request the comfortable chairs for you. Please don't fall asleep, but I won't take it personally if you do. But I have a little bit of audience participation just to get you thinking about the space. So this is going to be like a game on Price is Right called That's Too Much, I believe. What I'd like you to do is raise your hands and keep them up if you believe that, on average, customers waste at least 10% of their spend on Compute Engine. 10%. OK, so if you think it's at least 10%, but not more than 15%, put your hands down. If you think it's 15% or more, keep your hands up. OK? What about 20%? 30%? 40%? Yeah, so it turns out it's about 35%. Now, this particular stat comes to us from RightScale. They do a broad survey of cloud adopters every year. And the number that they actually measure with customers they're working with is 35%. Interestingly, it turns out that the customers they survey think the number is 30%. So they're already pretty pessimistic about their efficiency, but then they're not even as pessimistic as reality. So it shouldn't be any surprise then that those customers also say that 76% of them that spend control is one of their challenges. About a third of those say that it's one of their most significant challenges. And over half of them say that it's their top focus for 2018. So presumably, some of those reasons might be why you're here today. And so we're going to talk about some of the things that you can take advantage of on Compute Engine to address that concern. So before I go any further, usually this slide comes at the end, but this is an important enough topic. Obviously, we've put a lot of effort into making sure that we have a lot of great content for you here at Cloud Next over the coming days. And so I wanted to call out some of the other great presentations that you can either see here or catch on YouTube. They go into some of the more detail on some of the tools and techniques that are outside Compute Engine's features itself, but within our billing support systems that you can use to help you with this problem. And I'll give you a little preview of some of those at the end. So since food is probably on the minds of a lot of people here, or maybe not, because you just ate, I thought I would keep this a little bit light. I have a little bit of a metaphor running through as if this were a cooking show, and I'm going to teach you how to cook up an efficient cloud bill. So bear with me. I won't overstretch the metaphor too much, hopefully. But I'm going to start with sharing some basic ideas about cooking your bill, and then move on to some of the ingredients that you can play with to get the best outcome. And then I'll talk about some recipes that you should try at home. And then we have some gadgets at the end. So chopping onions, that's kind of where most people start for cooking. That's a good thing to learn. So what are some of the basic ideas about cost management that you should be thinking about as you're looking about how you use Compute Engine? Well, so first of all, we're working on pricing innovations. And when we're thinking about what do we want to do, we kind of keep three core principles in mind. And those are the ones you see here. It should be simple, it should be flexible, and it should be fair. So those are kind of big words, and they can mean a lot of different things. I'm going to tell you what they mean to me and to our team when we're working on these things. And we think that these are the ideals that represent what customers tell us they would like to have. And so we really try to keep those in mind. So that guy was pretty smart. He had a good idea. Simple is nice to say, but obviously cloud is a very complicated space. So what does it mean to have a very simple approach to pricing in a complex space? It doesn't mean everything is exactly the same price. It doesn't mean there's not any dials or knobs you can optimize. What it should mean is that the concepts are simple, that it's easy for you as a customer to understand how it works, how changes would happen if you make changes to your usage, and then it all kind of makes sense. So you don't have to have a PhD in economics, a PhD in physics, or a team of people figuring out how this works. You can kind of hold it in your head. That's the idea of simple that we're going for. So, like I said, simple to understand, simple to use, but powerful enough to meet your needs. And you have a lot of complex needs as a set of customers. There's a lot of different use cases, and so we want to be able to capture those and make sure that what you're getting works for your situation. But no rocket science and definitely not hidden costs. So then what does flexible mean? Well, like I said, across our customer base, there's a very broad set of different use cases. Not all businesses are alike. Not all teams are thinking about spending in the same way. That might be because the finance department or the IT division or whoever thinks about how this money is spent might have a different approach to how the controls work within that company. It might be that you're a startup and the finance department is Joe or Sally, and it's their credit card. Or it might be a much more complex situation. And we have another talk, actually, that talks about how you could scale that whole challenge. Also, your needs are going to change over time. So something that you bought 18 months ago or signed up for 3 years on, if it's not flexible enough, it's not going to meet your needs by the end of your time. So we think a lot about that. And what that really boils down to in our product is that you should be able to pay for what you need, not anything more, and you shouldn't have regrets when those things do change or feel like you can't make changes because then you wouldn't be efficient with your spend. And finally, fair. So I have I have 3 small kids, and my 5-year-old, I'm sure you know the phrase, but that's not fair. So we're working a lot on what the word fair means. It doesn't mean what he thinks it means. What it means in this context is what works for Google works for you. So Moore's law happens, prices go down. For our components, performance goes up. You should see that reflected, just as if you were buying the machines yourself. You should always be getting a great price, and you should always be getting a great value. So a lot of times we talk about price performance, not just price. That also has led to some of the innovative features that we've brought out, such as automatic discounts. You don't have to ask us or learn the secret trick to know how to use the discount. It just happens. We think that's a pretty cool innovation that is fair. If it's more efficient for us to run, we should give you some of that back as a discount. It also has led to us building tools like Rightsizing recommendations, which is if you're overspending, we will actually say, hey, you're overspending, you should stop doing that. That's a little counterintuitive for a for-profit company, right? We're telling you to spend less with us, but we believe that that is the fair and right thing to do, and that either you will use that somewhere else for something that is valuable to you, or we will sell it to another customer, and we're happy either way. And then finally, we want to give you smart tools and the data that you need to be able to monitor and control it, so that there's no questions about what you're spending. That's what we think fair means. Okay, so some terminology. Different people are at different places, but I want to highlight a few things that we have customer conversations with quite frequently. And the first one is, what's a core? What's a VCPU? What's a physical core? What's a virtual core, right? So on the left is a somewhat older generation x86 CPU. And if you squint, you can see here there are 4 what I call physical cores, actual execution units that have all of their stuff duplicated. It's actually a mirror image. And there's 4 of those on there. So a lot of times a customer will come to us and say, well, I have a 4-core machine. If you bought this processor, it would be called a quad-core Intel CPU. But there's a technology called hyperthreading, which I'm sure many of you are familiar with, which essentially allows each of those cores to run 2 different paths of execution at the same time. So in cloud, those are commonly exposed of as what we'd call a virtual core independently, or a vCore or a vCPU. So it's kind of a little something like that. So that's a 4-core processor. If we were selling that as a VM, which we wouldn't do because that's not enough cores to put in a server, but if we were selling that, that would be an 8 vCPU machine, and we would sell an 8 vCPU VM on it. Seems obvious, perhaps, but the difference is 2x, right? So if you're analyzing your costs incorrectly, thinking about what you need, the difference can be significant. And so when we're having conversations with customers about what size their VMs should be and how that scales, in particular if they're migrating something from an on-prem environment, this is a topic that comes up very often, so I wanted to highlight it here. So count those cores carefully. But the thing is, our hardware might be newer than what you have. Performance might be different. Your software may or may not be clock rate or thread sensitive. So it's not always quite as straightforward as 2x, and we'll talk a little bit later about why it's important to measure that, but it is important to look at this. Now, the other thing to keep in mind is that you may have software licenses. For example, Microsoft licenses, either for Windows Server or for SQL Server, tend to measure in terms of physical cores. Sometimes when you move to cloud, they decide to use that same license to apply to a virtual core, and that can change your costs. So it's another thing to be aware of. Also, I want to talk about analyzing your needs. So looking across clouds, for example, list prices are not exactly the same. The machines are not necessarily the same. The way that you pay is not necessarily the same. You're not actually likely to pay list price unless you're doing a very unusual usage pattern, but the list prices still are not the same. So if that's where you start your analysis, you're already not quite looking at it the way it's going to show up on your bill. You need to understand how the different clouds discount differently and what your usage pattern is going to look like. So this kind of leads to a similar tip, which is think about your analysis. Try to come as close as you can to modeling what your usage is really going to look like. A lot of times a proof of concept use case can help with this. So finally, that broad idea of understanding what your usage is. What are the underlying trends? How peaky or spiky is your workload going to be? And then once you understand that, it's important to also understand that the true utilization, what I'll call true utilization, is not actually how many cores you've deployed. If they're all idle, you're not getting any value out of those, right? And so the ROI on those you could call 0. You're paying for something you're not using. I would say it's actually negative because it's still burning power. And so when you're thinking about comparing one situation to another, it's important to keep that in mind. Finally, TCO. That's not usually what it stands for, but it's a very confusing topic, so that's what I'm going to call it today. So customers, oftentimes when they're calculating their internal TCO, this turns into a big conversation about what have they included, what have they not included. The point that I want to make here, though, is that even once you get that whole financial analysis right, you're kind of not done, because your on-prem configuration is a much longer time frame environment, right? So from your finance department, you'll hear, well, our TCO is X dollars or X cents per core hour, and that's on a machine that maybe has a 3-year or a 5-year depreciation schedule, depending on your refresh. But guess what? That hardware is out of date in 18 months. So you have it for another 1.5 to 3.5 years, and that's what you get on it. You're not getting performance upgrades. You may not have other accelerators that you can plug into it. You may not be able to upgrade your racks to have more power. You may not be able to change your networking gear. You may not be able to resize your disks by making a single click. So there's a lot of other limitations and flexibility you lose in that calculation, and that doesn't always show up in the actual dollars per watt kind of calculation. So it's an important consideration to keep in mind when you're thinking about whether the prices are apples to apples. Okay, so let's talk about some of the ingredients that go into our cost-saving souffle, if you will. First of all, the way we think about it at Google is there's a set of base resources. Pretty much, fundamentally, a computer is a processing unit and some RAM for data. And then there's some I/O that brings the data in and out, right? So in a lot of places where you might deploy, that ratio of how many vCPUs to how much gigabytes of RAM is fixed, or at least it's fixed among a small set of options. The problem with that is it might not match your workload. So that's one aspect. The second aspect is what we would think of as the attached resources, things that you could imagine you're plugging into a server. In reality, they may already be there, or your VM is just going to be assigned to a server that happens to have those things, and then you're going to use them when you need them. But how do you think about those? Are those essentially welded into the VM that you need to buy? Or do you get to choose dynamically or in a very granular way what you need and then pay for that? So looking at that and thinking about the problem that way and thinking about having a decomposed solution led us to looking at this idea of alphabet letters and shapes and sizes and Z1 and X7 and all of this stuff. And the fact that those have these pre-configured shapes of what you're going to get. You're going to get a certain vCPU and RAM ratio. You're going to get certain devices plugged in. And the providers that do it that way are trying to guess at what your use case is going to be. But they're doing one guess for a broad set of customers. And even within those use cases, things might be different. So if you want to use a bunch of NVIDIA GPUs, you might have very different use cases and very different patterns that mean you need more CPU, less CPU, more RAM, less RAM. So when you're thinking about cost, you need to think about the fact that it's not just the dollars per hour cost of that VM, that pre-configured shape. If you're not using some of those resources, you're just paying for waste that you don't need. Now, it turns out that getting this right and doing this in a decomposed way is a really tricky problem. Fortunately, Google internally uses a system called Borg to manage our fleet. And you've probably read a little bit about that in the press, maybe not. But that's how we managed our fleet for over a decade. And it's gotten very good at having flexible definition of what a job uses and how many resources it needs. And it understands how to pack those things together in an efficient way. And Compute Engine is built on top of that core technology, and it uses and leverages all of that. So for us, having more flexible definition of what a VM is was an easy thing to do because we already had that infrastructure there. If you don't have that infrastructure, making everything scale in a fixed size and ratcheting it up by powers of 2 makes for a relatively simple scheduling problem. And you can efficiently schedule the machine. The problem is any waste is the customer's responsibility to pay for, and that's not what we wanted to end up with in our design. Okay, so what are some of the things you can do with these ingredients, as it were, on Compute Engine to cook up some savings? So kind of the direction I've been leading with the last couple of slides is talking about where we landed with custom machine types. So if you haven't seen this feature before, essentially the idea is pick the ratio you want, decide what you want attached, and you're done. That's what you pay for. So we allow for any increments of either from one vCPU and then any multiple of 2 up to the largest machine size that we offer. And RAM within a very broad ratio of about 0.9 gigabytes to 6.5 gigabytes per CPU. So it's a ratio range that you can tune in quarter gigabyte increments. So what that means is pretty much any ratio you've got out there, unless it's 14 to 1, 16 to 1 on RAM, you can build your own custom machine type that matches that ratio exactly. Then you can pick how much storage you want attached to it. You can pick if you want local SSD attached to it, GPUs, cloud TPUs. You configure that, and then that's what you pay for. And we show you the prices of those individual units. So one of the things that we found is that this is very helpful for customers that are doing migrations, particularly from on-prem, where in the past, processor manufacturers have made machines that are 6 cores, or processors that are 6 cores, 12, 14, 18. Those aren't powers of 2. So if you're actually looking to migrate an existing application without many changes, the thing that might make the most sense is to be able to size it into a VM that exactly matches the same number of resources. And so this lets you do that. Now, we'll talk in a minute about whether or not that's as far as you could go in optimizing your spend, but it's a reasonable starting point, and it helps you already. So if you thought about what you'd do migrating to a cloud that didn't have that option, if you need 10 vCPUs, and your only option is one that has 16, you're already 60% over on the processing power. So what do? You squeeze it down to 8, you run 16 and hope it's okay, and just take the extra costs. You don't have to make that choice on Google. Another thing that we see is, for some reason, it's very strange, we're not really sure, a lot of people run 2 gigabytes per vCPU. And we do actually know the reason. It's because that's a ratio that exists on another cloud. So it's very easy to port over from that perspective as well. It's not a ratio that we offer in our predefined types, but it is a common ratio. So it can help with that too, if you just want to minimize your changes. The nice thing about this is you can also just optimize later. You can start where it makes sense, And then if you want to go spend some time maybe doing some deep analysis of your application later, figure out exactly how much RAM you really need, just move the dial, turn down the RAM. Or maybe you're finding that your server is sitting idle, you need fewer processors, move the dial, turn down the processors. And then a quick reboot and you're good to go. We'd like to get rid of the reboot, but it turns out a lot of guest operating systems require it, so maybe someday. But wait, there's more. We'll actually help you with this. So last year, we talked about right-sizing recommendations a little bit. At that time, the feature was in beta. It's now generally available. And this is actually a snapshot of part of the Cloud Console. And so the feature is the right-hand column. Essentially, we will watch your VM from the outside without seeing any of the data. We look at the usage of CPU utilization, RAM page utilization, and we can figure out how much you're leaving idle and not using. And after we've watched that for a while, we will make a recommendation to you about a different shape you could pick. Oftentimes, it's going to be a custom shape that will allow you to save money. We evaluate the RAM and CPU dimensions separately. So essentially, we're moving the knob for you on custom machine types. And then it's with one click, you can apply that. In addition, we currently have in beta this same capability, but for managed instance groups that are not auto-scaled. So auto-scaling is a little bit harder problem because you're essentially scaling horizontally. So what does it mean to resize any individual instance is a trickier thing. But we see people use managed instance groups for scenarios like a cluster of database machines, for example. It's not one that changes in size, but it might be that each of those individual machines are oversized in one or both dimensions. So that capability is also there. Now, one caveat I'll mention, and the other reason why we do have the button for you to click and confirm it is, there are outlier cases where you might actually intentionally want a machine to be over-provisioned. And an example I would give you is, if you have a certain latency target on, say, a query response from a server, you might need the processor to be not fully utilized so that you can hit that reliably, because when it starts to get highly utilized, then you're going to get more variance at your P90 or your P99. So there are some cases where that doesn't necessarily make sense, but for most people, this really helps you move the dial on what your spend is and how much is wasted. So another thing that we do a little bit differently on Google Cloud is to help you save automatically is sustained use discounts. So the core idea here is very simple. The more you run, the more you save. Up to 30% if you run a VM for the whole month. Now, it turns out that's fairly straightforward, but that use case of you have to run it for exactly the whole month might not always happen in production scenarios. Like, let's say you need to reboot or upgrade, or you move to a different zone or instance type. There are some of those scenarios where it wouldn't be fair, if you refer to the principles, for us to say, yep, nope, sorry, you don't get the discount because you didn't meet these tight criteria. The actual concept here is if your usage is steady, it's more efficient for us to provide the service for you. And so in that case, we're very happy to give you a discount. So we came up with a concept called Inferred Instances that actually looks at all the different instances that are the same size within a zone and looks at their usage together and tries to create the idea that these instances that were really separate but running at different times, they could have all been run together as if they were one, and it makes no difference to us. So we stack that together and give you the discount for the longest time span that we can find. The reason we can do this, incidentally, is because for us, this billing, discounts, et cetera, is just essentially a big data problem. It runs a big MapReduce. If any of you remember what MapReduce is, that's what Google calls Hadoop. And so it's very simple for us to just have something like this. It's complex for us to process, but simple for you to take advantage of, because it turns out we like big data problems at Google. So with that said, one of the things that we saw we could make better, and you'll see I was asked to put the roadmap note on the top of the slide. This is not available quite yet, but it's coming very soon, is we're moving from a model where sustained use discount used to combine only within a zone. We're moving to a model where it will combine across all of the zones within a region. And the idea there is, over time, we've made it clear that we believe the right way to build a highly reliable application is to spread your workload across multiple zones. And what we've seen is more and more customers are actually doing that. But the downside of that, and this goes back to that idea of fairness again, is if you did what we suggested you do to have a great service, you're going to be giving up discount because now your machines are across different zones. And in fact, maybe you're actually not multi-zoned for some of your things, but for one reason or another, you decide to move to a different zone. Perhaps, sometimes not all of our capabilities, like a GPU, for example, is available in every single zone, and you've started adding GPU usage and you want to move zones. Well, you shouldn't be penalized because you moved. So we're getting rid of that barrier, and we're moving SUD to change so that it works across all the zones in a region. And this will be rolling out pretty soon. I'm not going to give an exact timeline now, but stay tuned. There will be a blog announcement about that. And that's just an example of we found a better way, and we want to bring that to you. So I talked about those inferred instances a minute ago, and you can imagine that when we do that rollout, these inferences will now apply across all the zones in the region. And that's true, except I'm happy to report that I'm going to be able to retire this slide pretty soon. This is one of the oldest diagrams I think we have in our docs. It's kind of hard to read. It takes a little while to understand what it means. It turns out we have an even better idea. So we're going to be getting rid of this whole concept of inferred instances. And what we're doing instead is something we're calling resource-based pricing. So we got a lot of feedback from customers that you love sustained use discounts, but that diagram is kind of hard to understand, and more importantly, it's very hard for you to model. So a lot of customers like to have their own system, be it a spreadsheet or another mechanism, that essentially calculates what our billing system is going to calculate and helps you accurately predict what your spend is going to be. Maybe that's in order to model a new application you're deploying. Maybe it's because you're considering a migration. Or maybe it's just you like to have a different system that keeps track of what you think your bills should be so that you can look for any anomalies and try to understand them. So it's very hard to model, so we're getting rid of it. And what we'll be doing instead is actually a model that's very similar to what we already do with committed use discounts. And I'll explain that a little bit more in a second, but essentially, we're just moving to, it's all buckets of VCPUs and RAM, and we will look at all of your usage across time and give you the best sustained use discount you can. So a way to think of that might be low watermarks, essentially. So I have a simple scenario of what this is going to look like. And you can actually see there's documentation up for this today. But again, this will take a little while for us to roll out. One of the reasons we're talking about it today is because we recognize that this is a change to the system. And even though it's a change that's completely in customers' favor, it's different. And so we want to talk with customers, explain what's going to happen, make sure that you're all ready so that when this shows up, it's not a shock and it's not a problem if you're expecting something different on your bill. So just imagine this scenario. You're running a server. You happen to use one of our predefined types. Our mainline type is the standard series. So you have an N1 standard 4. It's 4 vCPUs. And this is a database server for your back end. It's not dynamically auto-scaled, but it's sized according to what you expect your load to meet. But you know that your CEO is going on Shark Tank in a week, and you're expecting a big hit in traffic, big jump up, and it's going to stay that way for a while. So you'd like to scale up to a 16 vCPU database because you believe that's what you're going to need. So how would sustained use apply in that scenario? So in the old model, these two instance types are different. And just assume for the moment that these are the only instances you're running. Obviously, reality is a little more complicated. But let's say that there weren't really any other 4 vCPU instances that you were running that would infer together with your database. And there weren't any other 16 vCPU instances that you were running before you upgraded your database. Well, in that case, if you switched in the middle of the month, you'd only get the 10% tier of sustained use discounts for each of those machines in that month. Well, it's kind of nice, but if you'd been running the database all month, you would have got 30%. So what if we just recognize that those 4 cores are still 4 cores, 4 vCPUs, and give you the max 30% on those 4, and then give you the 10% on the other 12. And then next month, you'd get 30% on those 16. That's essentially resource-based pricing. And it turns out, like I said, we already count this way if you're using committed use discounts. And in fact, if you are using committed use discounts, then sustained use discounts also already work this way for any usage that goes above your commitment level, because otherwise they wouldn't play together nicely. But now we're just rolling this out for everybody, so all usage will see this. So if you'd like to know more, the docs link is up today. There are a couple things you should think about, how this fits with your model, with your tools. To give you one example, which is also mentioned in the docs in more detail, if you're using BigQuery billing export, if you're looking at the SKU to understand what kind of machine you're using, those SKUs are going to disappear. You won't see an N1 standard for SKU usage anymore. All it's going to be is 4 units of VCPU usage. So it'll say something like VCPU North America is 1 core. There is another field, though, called machine spec. It's a system tag that comes out that tells you what that machine was configured as. So if you're looking for detailed machine information, you may want to use that tag, or you may, label, or you may want to set up your own labels to make sure that you have the metadata you want in order to analyze your billing. And that's an example of one of the reasons why we're previewing this announcement. So we like SUD, our customers like SUD, but then they also said, hey, it resets every month, but I know I'm going to be running this workload for 12 months or more. Can you do like a mega sustained use discount, like just super sustained? So we thought about that for a little bit. We started talking to customers, and they said, oh yeah, also, can you do it without any machine size restrictions and no zone restrictions to get the discount? I want to be able to move things around, and I don't want to pay you all up front because, cash flow. So basically all the flexibility and no restrictions. Can we have that? So we thought about that, and we said, okay. So that's committed use discounts. We introduced this product last year. Again, it was a product that was in beta at the time Next happened, and it went GA before the end of the year. Essentially, the concept here is we give you the maximum flexibility and the maximum discounts that we can. All we ask is that you tell us if it's going to be 1 year or 3 years that you're willing to sign up for, and the discounts vary between those two. And you tell us what region, not which zone, but we do have to do some capacity planning to make sure that those machines are there. And then tell us how many vCPUs and RAM you want. And now you'll see where this is the mirror of resource-based pricing for sustained use discounts. It's just vCPUs and RAM. You use it however you want. That's it. So thinking about those principles I mentioned, seems pretty simple, hopefully. Just a few decisions to make that you should have a pretty good idea of if you're looking at your workload, analyzing your bill. One of the nice things about this is because what we find is that it has enough flexibility that you can pretty safely buy up to the low watermark of your monthly usage or usage over some period of time that you believe is representative of your needs, and be pretty sure that all of that is going to be used. So we have a number of customers that tell us that they're regularly seeing well above 90% utilization on their committed use discounts, and that's very different than some other discount products that they've played with. So the other thing is, if you're growing your deployment, you may want to come in and update that over time to cover as much as your base usage as makes sense. So they're flexible. You can change shapes whenever you want to. The discount's not tied to a specific VM. You don't have to specify anything at runtime. There's no tagging that says this VM is a committed use discount, this one isn't. The way it works is we do it fairly. And what fairly means is we analyze this over the entire time span of your usage. And at any point in time, we take the first X vCPUs and the first Y gigabytes of RAM that meet your commitment, and we apply committed use discount across all of those. If some VM is temporarily contributing to that, and that VM stops, and there's another one that wasn't in the consideration, it automatically gets considered. So you're always getting a maximum use of your committed use discounts. And then finally, the sustained use discount applies on any usage that's above that threshold. So referring to that idea I mentioned a minute ago of the low watermark, if you know where your baseline is and you see some usage over that, you can rest assured that that usage will still qualify for sustained use discounts if it is a significant enough period of the month to qualify in a normal sense. So this was one of the quotes from our launch article, just to give you a sense of what our customers thought about that. I think we kind of hit the mark. I like the last sentence the most. So another recipe. Last year in this talk, I would have said leverage preemptible VMs. This is my favorite product. This is our best product. This is also the very first product I launched when I got to Google, so I might be biased. But we introduced this over 3 years ago, and the concept is really simple. If your workload can tolerate interruptions, then we will give you up to 80% off of the cost of the VM for you to run a preemptible VM. There's no auctions, there's no bidding, there's no uncertainty, except there is a small chance, usually around 10%, that you might get preempted with some of your VMs earlier than the 24-hour window. So if your workload is prepared for that, this is a great option. Now, the reason I'm not saying VMs anymore is because our customers have told us they love this idea. In fact, I was walking over here earlier, a customer was telling me, we love preemptible VMs, we can't get enough of them. We extended this to our other resources. So this is now a general pricing concept in our infrastructure layer of preemptible resources. You can also see it reflected into higher level services that use preemptibles, such as GKE. So beyond CPU and RAM, we now have GPUs that you can get preemptible, cloud TPUs you can get preemptible, and local SSD. So what those mean is if those are attached to a preemptible VM, you will get the preemptible price on those resources, and the other rules around preemptible shutting down early are the same. Now, one other thing, I had a slide that I was preparing for this. I didn't quite get a chance to throw it in. We made an announcement today, which may have gotten lost in the noise of many other announcements, that the cloud TPU prices here are actually wrong. There's a promotional price going on right now where that normal price is $450, and the PVM price, I believe, is down to $135. So check that out if you're interested in cloud TPUs. But in general, we continue extending this, and you may see it in other places in the future. So lastly, we'll do a little Q&A. Thinking about tooling. How do you use all this stuff? How do you know that you're getting the savings you hope for? So the first key, and I put this one first, not necessarily because it's the first thing you're going to use, but it's the first thing that I recommend that you do, is run to the Cloud Platform Console when you start setting up your project, turn on BigQuery export. Now, I will tell you this comes with a small cost. It is going to store some data in BigQuery, and you have to pay for that storage. But the advantage is if you turn this on right away, then even if you don't get around to starting deep analysis of your costs for a few months, all that data will be there in BigQuery waiting for you. So I highly recommend you do that. It gives you much more information, and there's a bunch of tools that you can use that leverage BigQuery that will go much better for you than extremely dense spreadsheets, which is what everybody seems to use otherwise. So can't underscore that enough. Second of all, I don't know what this picture is. I was thinking maybe it was like King Tut's tomb or something in the different rooms. No, actually, this is a slide I stole from the IO 118 talk, which I believe is the one that already happened this morning. But that talk is all about how to organize your resources using the different features we have, such as organization nodes, projects, folders, labels, so that you can do really meaningful analysis of how your utilization is working. So I definitely recommend checking out that talk. And it starts, like I said, at the sort of two-person shop and builds up to a large organization, multiple billing accounts, those kinds of things. So it's great to get a sense of how do I organize this so I can analyze it later. Finally, we have some features around being able to set budgets and then being able to get alerts and notifications on those. And then you can have automated responses as well. And so this is a slide that I stole from the IO 103 talk, which has not happened yet. So I would definitely recommend checking out Stephen's talk as well. And there's a rundown of all the different sessions that talk more about all the different billing techniques and tools that you can use to understand cost. I would also recommend, which one is it? I believe it's IO 208 that has a customer named Vendasta. It's Dale and Dale from Vendasta, and they're very funny guys. And their talk is, look at all the, as described by them yesterday, look at all the stuff we did wrong. Here's how we found it. Don't do this. So that's pretty interesting sort of lessons learned about analysis and billing. So things where they found, oh, look, we were storing 10 terabytes of extra log data that we didn't know about, and the list goes on.